Are your electronic devices sad, depressed, or alone because they have no internet friends? Are you unable to connect them to the World Wide Web because of your limited knowledge on networking? And most importantly, are they unable to function correctly because of their lack of connection between each other? Well then you need to watch this course. This course will teach you everything about networking and how to get your devices connected. Make your devices happy once again by allowing them to communicate with each other and get the extra bonus of learning how to connect them to run your light show. So what are you waiting for? For a limited time, for $99.99.99, you can get this course at www.thisisthebestnetworking-series about learning how to connect the light show and your devices together to make them happy.com. Or you could just watch it for free right here on YouTube. Hey everyone, thanks for watching How To Pixel. My name is Nick, and in today's video, we're going to be diving into a topic that I've been holding off for a while, and that is networking. The reason I've held off on this video is because I wasn't sure how to make it. It's such a big topic, and I didn't know what to include, how advanced to make the videos, if I should try and cram it into one video or not. But I finally decided to start making the video about it, and this video is actually going to be the first in a series about networking. There's a lot of different pieces to networking, and I didn't want to put it all into one video because I've made a lot of long tutorials in the past, so I thought it'd be better to break it up into different pieces. Now, most of this series about networking is going to revolve around pixels and light displays and how you get all of your controllers and computers to talk to make all of your lights flash. However, this first video isn't going to have much to do with light shows or anything like that. This is going to be a complete basic introduction into networking for anyone who's new to it and has no idea what there is to it. I'm going to be going over what a network is, what all the pieces are that make it work, what IP addresses are, gateways, all of that fancy terminology you've probably heard, and how everything comes together to make a network work. If at any time you want to skip to a certain part of the video or go back to rewatch something, feel free to use the timestamps in the scrub bar and in the description below so you can get right to what you want to see. One quick disclaimer before you get started, I am not a network engineer. I don't study any of this. I figured out how all of this works by watching YouTube videos over the past years so I could set up my light show. So there's a chance in this series I might get a few things wrong, and if I do, please feel free to correct me in the comments. But with all that out of the way now, let's get right into this networking series and start out with, what is a network? A network is when two or more computers or electronic devices are linked together to transfer information and data between each other. This can be done through radio waves, satellites, cables, and many other different ways. So when you think of the word network, it's not just your home Wi-Fi that's considered a network. A network is everything from something as small as that all the way to the entire internet that links millions of computers together to transfer data between each other. Even systems as big as GPS can be considered a network since it's millions of computers connected together to transfer information between each other, even though that's done through satellites. So that's what a network is. Great. But how do they work? So there are tons of different types of networks out there, and I'm not going to explain most of them because I'm probably not the qualified person to, and most of them aren't even that important to us. I'm only going to be talking about home networks in this video, and maybe possibly go slightly further into networks out on the internet. So a home network is your network that's inside your house, and it's what allows all of your devices to be connected together, such as your computers, phones, tablets, smart speakers, fridges, all of the fancy things that need Wi-Fi. Everything is connected on your home network. I'm going to assume everyone watching this video doesn't have much, if any, network experience, so I'm going to try and break this down as simple as possible for how a home network works. So I want you to imagine a giant highway. This highway right here is the internet, and it has everything you want on it. Everything from the next episode of your Netflix show to random questions you might search up on the web. And then beside the highway, we have some houses we want to connect to that highway. The houses can represent the different devices in your home, such as your phones, tablets, computers, all that stuff. Now these houses want to be able to connect to the highway just like your devices want to be able to connect to the internet so they can transfer information between each other. Except with the highway and house example, it's more like people wanting to go places. You can think of the people as data. But how are we going to do this because there are no roads connecting the houses to the highway? Well, first, let's put a road between all of the houses right here. So now we have this street here that at least allows the houses to transport people between each other, but we still can't get to the highway. You can think of this street right now as your home network router. The router connects your devices together just like this street connects the houses together. This is great if you have two devices on your network that want to transport information between each other, such as you trying to send a picture from your phone to your computer. But we still can't get out to the main internet or the main highway. So what do we need to get the router to connect out to the internet? We need a modem. A modem modulates the data from your router to send it to the internet, and it demodulates data coming from the internet to send to your router. The word modem comes from modulate and demodulate put together. In our little neighborhood example, the modem can be considered the on and off ramps to get onto the highway. On and off ramps like these allow cars to speed up to get onto the highway, and cars to also slow down to get off the highway and get to smaller neighborhoods. Well, a modem basically does the same thing. It speeds up data coming from your router to send to the internet and slows down the data coming from the internet to be able to go to your router. And there we go. The houses are all connected together so people from one house can go to another, and all the houses are also connected to the highway so the people can get out onto the highway. Just like all of your devices are now connected to your router, and your router is connected to your modem to go to the internet. In the real world, it would look something more like this. You have a coax cable that goes from the telephone pole into your house, and that coax cable plugs into your modem. You then have an Ethernet cable connect the modem and the router together, and then all of your devices can connect to your router with either Wi-Fi or through an Ethernet cable. You can buy a modem and a router combined into one box, but for most people, you usually have a separate modem and a separate router. So that's the basics on how a network works. There's still a lot more to it though, like how the devices communicate with the router and each other, and that's some of the more advanced stuff we're going to get into now. I'm also going to explain some of the terminology and different things you'll hear in networking. So there's a lot of different terminology and things you'll hear about in the network space. Some of them are easier to understand than others, some are more advanced, but I put together a list of a few of them I want to talk about in this video. This list does not come close to including everything in a network, but it's what you'll need to continue on with this series. So here's what we're going to talk about: IP addresses, gateways, netmasks, DNS servers, SSIDs, DHCP, ETH0, and WLAN 0. I know that's probably a huge list, but I'm going to explain everything in this video so you'll understand it. So first, let's get started with IP addresses. IP addresses are like the main address every device on a network uses so they can communicate with each other. They're kind of like your own house address, and that way the post office knows where to send the mail based on the address. There are two different types of IP addresses out there. There are public IPs and there are private IPs. Private IP addresses are all the IP addresses within your house and within your home network that connects all of your devices to your router. Public IP addresses are the one IP address each network has to connect all of the networks together in the internet. So if you go back to our neighborhood example and you were to give each of these houses an address, all of these are considered private IP addresses because they're within the private network. Now let's give this neighborhood a name. Let's call it Networkville. This address, Networkville, is like the public IP address. For all the cars that are zooming by on the highway, if they want to get to this area, they're going to go to the address of Networkville. And then once they're inside of Networkville, if they wanted to go to one of the houses, they'll then go to the private IP address, which is the address of the houses inside. If that seemed too complicated, just think of everything inside your house has its own IP address, and then your whole house has one grand IP address that gets out to the internet. The one IP address is the public one, and all of the devices inside are the private IPs. Now I'll talk about how you get private IP addresses for your devices later, but for your public IP address, like I said, your home network only gets one IP address, and this is given to you by your internet service provider. Your router is the only device on your network that gets that public IP address. So if you wanted YouTube to send you a video to your computer, let's say this video for example, YouTube wouldn't send this video to your computer's address. YouTube instead sends that video to your public IP address, to your network, and that video goes to your router. Your router then determines which device within your home that video needs to be sent to. Now, these examples aren't just for YouTube. This is how every website on the internet sends you data. If you have a device on your network that's asking a website to send you some sort of data, that website is going to send it to your public IP address, your router is going to get that, and then your router is going to determine, which of the many devices on my private network do I send this to, on my home network? And then it's like, oh yeah, this computer asked for this, so I'm going to send this information to this computer. Now you might be thinking, oh no, what if someone gets my public IP address? Can they access all of the devices on my network? No, because of something called the firewall.
Welcome to the firewall.
But for now, let's not worry about that. Now, what are the numbers that make up an IP address? What does an IP address look like? Well, first, I have to tell you about the different versions of IP address. There's IPv4 and IPv6. An IPv4 address you're probably more familiar with, and it looks something like this. An IPv6 address, however, looks something like this. A lot more different characters to it, so it's a lot more confusing. However, because of the many devices and networks being added to the internet and to the globe every day, we are slowly running out of IPv4 addresses because the numbers are smaller. There's less options for them since it's only 12 digits. However, IPv6 is bigger, so you can have more options for it. But IPv4 is still common because we haven't ran out of addresses yet. More devices are switching to IPv6 because of this, but IPv4 is still very popular, and it's probably what your network uses, so that's what I'm going to talk about. So these IP addresses are made up of 4 groups of numbers called octets. Each octet is a 3-digit number that can range from 0 to 255. So the range for IP addresses can start at 0.0.0.0 and go all the way to 255.255.255.255. Now, what do public IP addresses commonly look like? Well, they can literally be almost any number within that range, with a few exceptions. So your public IP address could look something like this, or it could look something like this, or it could even look something like this. Now, private IP addresses are more limited. There are set ranges within that 0.0.0.0 to .250. I'm not going to say the whole number. There are ranges within there, though, that are set aside for private IP addresses. They're split up into 3 ranges, and they're called Class A, Class B, and Class C. I'll put the ranges on the screen. Most of you are probably going to be using range C, at least for your private IP addresses. This range is the most common for private IP addresses, and that's what it looks like on most routers or when you look on your phone what your IP address is of that device. Almost every private IP address starts with 192.168.something.something. So the first 2 octets are almost always that number. Now, your home network may be in one of the other ranges. It really doesn't matter. It's just however your router is programmed to give out private IP addresses. Just know if you're setting up your device's IP address, the first 2 numbers should always be the same across your entire network. Actually, most time the first 3 numbers should be the same, but I'll explain what all that means in a few seconds. So I talked about what the first 2 octets commonly are, and like I said, yours may be different, but let's move on to what the third octet normally is and what that does. The first 2 octets are almost like identifying which class of IP address ranges you're in, but the third octet identifies what subnet that IP address is on. I'll explain what that means in a second, but I'm going to go to the 4th and final octet first. The 4th octet of an IP address is the actual identifying address for each device, and each device will get a unique 4th octet that won't be the same as the rest. So if you go back to our house's example, we have all the devices on our network within Networkville. We have a phone, we have a computer, a TV, and a tablet. The first 3 octets for these devices are going to be the same, but the 4th one is going to be different because that's the unique number each device gets. So this one could end in .42, this one could end in .79, this one could end in .212, and then the other one could end in another one, as long as it's different from the rest of them. And that's because that octet is almost like the identifying number of that device. The router is able to tell which device is which because of that last identifying number, and since it's different for each device. Now, what can the last octet be set to? Well, I said earlier, each octet can range from 0 to 255, but when you're setting up a private IP address, for the last number, you cannot use 1 because that's usually the unique address your router has, and 255 is a special broadcast address, which we won't get into now. So your devices can have the last octet be anything from 2 to 254. Anything bigger than 255 is not possible because IP addresses don't go that high. You're probably super confused now, so I'm going to go back to the neighborhood example again. The first two octets stay the same for every house, and I'm going to make them 192.168 since that's the most common. The third octet that I didn't really talk about almost is like the street identifier and identifies which street the house is on. So within your private network, you can have separate subnetworks, and that's where you get the subnet. That's why I said the third octet is the subnet identifier. If you were to have multiple different networks within your home network, you could think of this as multiple different streets. Now this street could have the subnet number be 1, because this is street 1. And then for your second street, you can have the subnet number for this be 2. It doesn't have to be in order, it could be any number between 0 and 254, as long as they aren't the same and they're unique across the different streets. But if you have many different streets, more than just 2, the third octet has to be different for the devices on the different streets. So this is street 1, the octets for the first two numbers are always going to be 192.168. Since this is street 1, we could set the subnet to 1, and then the unique fourth octet can be anything between 2 and 254 as long as they don't repeat within that street. But that means when you go on to the next street and you have a different subnet number, these devices can now use the same unique address even if that number is already taken by a device on the first street, because as long as they aren't the same within that street, they aren't going to mess with each other. So the third octet is like the street identifier, the fourth one is the unique address each house gets. For most networks, you're only going to have one street. If you have more than one street, you usually need another router for each street. But if you just have a simple network, then all three octets are going to be the same and you don't have to worry about that. However, if we set up our own light show network, like I'm going to show in future episodes, we are going to have a separate street, but we'll get into that later. So that is everything for an IP address. That is the difference between public and private IP addresses. And now we can move on to some of the easier terms. IP addresses took a while, but now we are going to move on to talking about gateways. So if you've ever set up a device manually to connect to your router, like a Raspberry Pi or a light show controller, you'll know it asks for an IP address, but then it also asks for a gateway. The gateway is something on your network that routes all of the data between all the devices, figures out where it needs to go and if the data needs to go out to the internet or if it's staying local within the private network. The gateway routes all of that. The gateway is actually really simple and it's just your router. Your router is the gateway that routes everything where it needs to go. You can think of it as the gate from your private network to your public network. So when a device asks for a gateway, it's simply just asking for an address of a device that can route the information for it. And almost every single time, that's going to be your router. So if a device is asking for a gateway, all you have to put in is the router's IP address. Next is the netmask, and it's another number like IP addresses and gateways that has 4 octets in it. What the netmask does is it defines what part of an IP address is the network part and what part of an IP address is the host part. Remember how I said in an IP address, the 4th octet is the unique number that identifies which device is which? That's also called the host. The rest of the IP address is just the network part because it defines what network the device is on. Now for some networks, instead of having just the 4th octet be the identifying number, you can have both the 3rd and 4th octet be the identifying number. Sometimes you can even have the last 3 octets be the identifying number and the first one just be the network part. That's usually useful if you have more devices than you have for IP address numbers. Like I said, you can only use 2 to 254 for the identifying number. So sometimes you'll want the 3rd and 4th octet to be the identifying number. That way you can get even more addresses. Now for us, we're probably never going to have that many devices on our network, so we'll only need the 4th number to be the identifying number, the host. But you still have to know what the netmask is because a lot of devices will ask you to put it in. Like I said, the netmask is to just define which part of the IP address is which so the device knows which part is which. So for our networks, if we wanted the first 3 octets to be the network portion and the last one to be the host portion, we would set the netmask to 255.255.255.0. If an octet within the netmask is 255, that means that that same octet for the IP address is going to be a network part of the IP address. If an octet in the netmask is 0, that means that same octet in the IP address is going to be a host part of the IP address. Now you can set the number to other things between 0 and 255, but it gets too advanced. We don't have to worry about that. So if we wanted the last 2 octets to be the host, we would only set the first 2 octets of the netmask to 255.255. The other 2 octets would be 0.0 to explain that this is the host portion of the IP address. However though, if you're just going to be a normal person and leave the 4th octet to be the host, then you can always set your netmask for every single device to be 255.255.255.0. Now let's take a break from the harder terms and move to some of the easier ones. The next one you'll commonly hear in networking is SSID, and it stands for Service Set Identifier. It's basically just a fancy word for network name. Whenever you go to log into like a Wi-Fi network and you're scrolling through and you see all the different Wi-Fi networks in the area, those are all SSIDs. So if a device asks for an SSID, it's just asking for the network name, except with a fancier word. Next is ETH0 and WLAN 0. I just added these because you'll see these a lot when you're setting up a Raspberry Pi with Falcon Player to run our Christmas light displays. ETH0 just means the Ethernet interface and WLAN 0 means the Wi-Fi interface. So if you're in the network settings of your Raspberry Pi or any device that has these terms, if you see ETH, that means Ethernet, and then the number means the interface number. So if your device has 2 Wi-Fi chips, the first one would probably be WLAN 0, and the second one would be WLAN 1. Now I only have 2 items left I want to talk about, but these ones are a bit more complicated. First is DHCP. DHCP stands for Dynamic Host Configuration Protocol, and it's a super useful thing. We use it all the time. You've probably been thinking this entire video, wow, this information's nice, but when am I ever going to use it? Whenever I want to connect a device to a network, I just put in the Wi-Fi name and the password, or just plug in Ethernet, and it connects by itself. I don't have to put in the IP address or any of that. It just does it automatically. So why do I need all of this? To answer the question about why you need all this information, just trust me, you'll need it later on in this series, and I'll explain a little bit why later. But now when you say everything just happens and it magically connects by itself, you don't have to put in the IP address, gateway, netmask, any of that, well, that's because of DHCP. So how does DHCP work? Well, if you have any device you're connecting to your network, whether it be with Wi-Fi or with an Ethernet cable, that device will send a message to your router requesting for an IP address. If your router has a DHCP server inside, like most do, that will answer the request and it will look through a range of IP addresses it's allowed to give out. When it finds an open one, it will send it to the device and say, hey, is this IP address good? If the DHCP server and device agree, the DHCP server will then give that IP address to that device, and then it will take it off the list of available IP addresses. DHCP keeps track of all the IP addresses in use and hands them out to all the devices. If the DHCP server doesn't detect a device on the network after a period of time, it'll remove that IP address from that device and let it become a vacant IP address again, so a new device can use that one. Now, in that range of 2 to 255 for IP addresses that your router can send out, the DHCP server will usually be set to only use a range of those and not the whole thing. But most routers, you can go in and change this so it can have more IP addresses or less IP addresses to use. So DHCP is very helpful because when you connect a device to your router, DHCP is really doing all the dirty work for you, so you don't have to go and check to make sure an IP address is available, then put it into your device, put in all the other information. DHCP will do it for you. Now with most devices, there's usually a way to select to do it manually, so you can put in the IP address and all that information if you don't want to use DHCP. That's also why DHCP is limited to only a range of IP addresses. That way there's another range that's never used. So if you want to manually set up an IP address, you can use that range. You can also use the range within DHCP and it will realize, hey, there's a device using this IP address, I should take it off the list of available IP addresses. Now if we go back to earlier when I was talking about why do we need all this information if it does it by itself, I said, trust me, you'll need this information. And the reason why is because when we're setting up our light show controllers, our Raspberry Pis, whatever we have, we usually can't use DHCP. The reason why is if you connect your device with DHCP, the IP address can change. If the device turns off or DHCP decides to change the IP addresses, the IP address is going to change. And that's a problem because we need to know the IP addresses of our devices. Like if we have a computer sending a controller data, we need to tell the computer what the IP address of the controller is to send the data to, and DHCP could change the IP address of the controller. That's why we have to set it up manually. That's why we have to know all of this information. But let's not worry about that for now. Let's go on to the final item on the list of items we're going to talk about in this video, and that is DNS servers. DNS stands for Domain Name System, and it's basically the phone book of the entire internet. So remember earlier in this video when I was talking about how your entire network has one public IP address for websites and other things on the internet to access your network? Well, the same goes for all of the websites and things on the internet out there as well. Every single website has a public IP address, and big ones like YouTube and Google and all of that stuff have multiple IP addresses since they have multiple servers across the globe. So whenever you want to go to YouTube's website, let's say, you technically have to type in the IP address of YouTube's server so your router knows where to send the request to. Because if you tell your router, hey, connect me to youtube.com, it's going to be like, what is that? It's almost like if you were to get into a taxi and the taxi driver was to ask, what address do you want to go to? You were going to tell him, my house. The taxi driver would have absolutely no idea where that is because it needs an actual address. Well, so does your router. It needs an actual address, so you can't type in amazon.com, youtube.com, any other website. You can't type it in because the router won't know where to go. Well, somehow you are able to do that. So what makes it possible to be able to do that? Well, it's DNS servers. DNS servers store every single website's IP address out there. If you get a new website and you have a name for it, you have to register it with a DNS server so that way the DNS server can know your website's IP address. When you type on your computer www.youtube.com and push enter, your computer sends a request to your router to connect you to youtube.com. Your router sees www.youtube.com and it's like, I have no idea where that is. I don't know what IP address that is. I'm going to send this to the DNS server and ask if the DNS server knows. So your router will then ask a DNS server for the IP address of youtube.com, and the DNS server will be like, oh, you need that IP address? Okay, here you go, and give the router the IP address. The router then knows where to go with that address, so connect your computer to that IP address, which would be YouTube servers. If you visit websites often, your router and sometimes even your computer will store those IP addresses until you don't use them anymore. That way, every time you want to connect somewhere, you don't have to ask the DNS server. You can save time by already knowing that IP address. That's the overview of how DNS works. I think there's some other steps to it, but I'm not fully sure. DNS is one of the things I don't know everything about. But if a device asks for a DNS server address, like sometimes Falcon Player does, if you're setting up your network manually, what it's asking for is an address of a DNS server that it can talk to figure out the IP address of websites. But that is what a DNS server is, and that concludes the very long list of items I wanted to talk about within networking. I know there's a ton of information packed in here, and each individual item I probably could have made a separate video for, but I also didn't want to have a 100-episode long series. So if there's anything you're confused about, if you have any questions or comments, please feel free to leave them in the comment section below. Also, like I said at the beginning, if I'm wrong on anything, please point it out in the comment section below so I can fix it. But now that you know the basics of networking, the rest of the episodes in this series should make a lot more sense. For the next episode of networking, I'm planning on making a tutorial on how you connect your Raspberry Pis or controllers for the first time when you get them. And then later on down the road, I want to build up to making your own light show network, like I said. I might have some other episodes in between. I'm still trying to figure out what other details I should make before, so there's not one long confusing video. If the next episode of the series is already out, I will link it right here, or it might be on this side. I can never remember. But that is going to conclude it for the first episode of this networking series. Thank you for watching, and I'll see you in the next video.